follow up. There we go. We'll go ahead and get the lesson started here. So it'll keep an eye on whatever I have here on the shared screen. It'll often tell you things like mandatory update. Ignore those. I've tried updating that a few different times, and 3D Experience always has some weird stuff. Okay, so one of the other things that it will do is it'll come up with this home screen. So there's an example part that I was working on. We'll do something sort of similar maybe for one of the examples, but first we're going to do just a basic example. While you're installing, many of you have probably already fallen into the IPS trap. Let's see. Josh, do you know what the IPS trap is in SolidWorks when you do the install? It's not actually something they cover in the CSWA. So one of the things that you'll want to pay attention to, some of you have probably already clicked past it, not knowing what's happening. It will sometimes set the default to IPS, which is inch, pound, second units. So you want to make real familiar with this box down here and switch to MMGS when you open the program. And what that'll do is that will keep track of dimensions. I think in almost every circumstance, the drawings that we're going to give you are going to have things in MMGS. So there are a couple other kind of quick housekeeping things as we get started. Like I said, this one's going to replace the other week one video that I had from earlier in the week. There was much chaos, interruption, and malfunction because of the screen mechanics and Zoom helping and all of those things. So this one should go a lot smoother. Mouse, you want to get yourself a mouse. I highly recommend a wired mouse. It's fewer parts to lose, doesn't require batteries that are often dead, and is not really any more expensive and fits your hand way better. They really don't weigh a whole lot more, and it's a cool, legitimate excuse to say, hey, my professor told me I had to have a mouse. And so you can get whatever that particular gaming mouse is and say, no, really, it's for SolidWorks, right? I need all the buttons for, dimensions and stuff. And then you can tell your parents I said so. Just don't redirect them to the video where they see the explanation, because you don't actually need all of the buttons. So you want to make sure that you are able to use a mouse, because you can do this on a trackpad to start with, but you're really going to hate life. If you're trying to install this on a Chromebook, you're going to run into a hard stop. Just go back and talk to your SSC, because you're going to have to either delay this another semester, or you're going to have to go out and buy some actual laptop with a bit of hardware underneath it. If you guys are running on an older computer, there's a number of students that are on kind of older Mac systems or something. There are a bunch of things out there to buy. There are a bunch of things to definitely not buy. So especially the stuff that's running on ARM processors. You guys can send me a message through Halo, and I'll be able to give you more detailed recommendations on laptops if and when you need them. There's a bunch of stuff that I use that works really well. There's a bunch of laptop brands out there that are not very good at all. And in engineering, Chromebooks are virtually useless. So now with all that out of the way, here's what we're going to start with. So there's a bunch of stuff here in the interface that I want you guys to be familiar with. Sometimes you'll almost never have that pinned when you start out and things like that. I recommend opening this up and pinning it. No, you don't need a 3D Experience ID. It will try and have you log in and do all kinds of strange stuff. You should be able to skip all of those steps during the install. So what we're going to do is spend most of our time. I recommend having this pinned because there's a bunch of tools, and insert are things that you're going to use pretty frequently. Not all the time, but pretty frequently. And one of the ones I recommend having that we're going to get into the use of today is this one that's under View and then Toolbars. When the Command Manager, which is this top ribbon, when this goes away and you don't have it pinned or you can't find it, go back to View. This is something that happens to students, and then they spend like 25 minutes trying to figure out what happened. You need to make sure you have the Command Manager visible. And then because of how often I use it, I recommend having the reference geometry here. So that's what this menu is. And we'll get into how to use it here in a little bit. So some quick fundamentals. 95% of the time, you're going to be, I guess maybe closer to 80% of the time, you're going to be in Sketch. 20% of the time, you're going to be in Features. Later, we'll see how to use some of these other things, but most of the actual simulation we're no longer doing in this class. We're now doing it spread around into the other classes. Bunch of reasoning behind that. So Sketch is where we're going to start almost everything. So there's some nomenclature that I will use. This will kind of help to clarify things a bit. You start a sketch by hitting Sketch. There's a couple other ways. So this is what I will call stepping into the sketch that you're going to be working on. We need to think in terms of which plane we want to be on. So what you want to do first is you want to think about what it is that you're drawing and think about what kind of symmetry that it has. So if you're looking at the camera, if you start out with a part like this, see if I can get it to sort of focus, that has compound curves, it has hardware associated with it, it has different cutouts, different like 5 or 8 different geometries involved with it. What this is going to do is it's going to allow you to have a few different geometries, but it's also going to limit you in how you can approach it without making life very, 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 very hard on yourself. So one of my goals this semester is not necessarily to teach you that there's one way and one way only to do something, but I'm going to try and teach you that there's a smart way to develop your drawings and then a not as smart way. So something can take you several hours or something can take you several minutes, and it's up to you to start learning how to think in that way. So if I were to start recreating something like this coffee mug, I'm going to look at it, and there's a couple ways I can take advantage of the symmetry. For the fundamentals that we're going to start with, I'm going to start from the top plane because that's looking down from the top of an object. And what I can do is I can come up here and add some of these sketch elements. So each of these has drop-down boxes for different versions of things. Lines, center lines are used all the time. Center point arcs and 3-point arcs I use all the time. The default here is corner rectangle. There's polygons, there's some other things, texts and points in space. So all of these have places where they will be useful for specific kinds of geometry, and we're going to learn how to use them throughout the course of the semester. But we want to start just by selecting our plane, selecting what sketch element is that we want, in this case, a simple circle. And we're going to start by selecting the origin, because what this does is that little yellow box that'll be almost impossible for you guys to see tells us that we have a coincident point there. And there's a couple other varieties. So we have the vertical bar and we have the horizontal bar. Horizontal bar shows up when this reference line is perfectly horizontal relative to the origin. Same deal here, whether it's perfectly vertical. So those become very, very important, not for when you're working with a circle so much as when you're working with something like a rectangle. So I'll do a quick rectangle. You can touch on a point with the mouse and then draw what's effectively a leader line or a reference line out, and it will tell you, hey, I'm horizontal and I am corresponding with these two features of the circle. So the upper radius and then the origin. So there's a lot of reference points that we can use. And when we go to start doing smart dimensions, which is one of the things that we start doing immediately, we say, actually, this needed to be 45 millimeter. Now what this has done is, because of that referencing, this has become half of that, which is our 22.5 millimeters. So the smart dimensions allow us to change a sketch from blue to black. Anyone remember what blue to black change means for a sketch? What does that tell us about its properties? Let's say that needs to be 30 millimeters. Fully defined, good. So fully defined is very, very important. Fully defined allows us to do a few different things. And this helps when you go to do more complicated 3D geometries. What this can do is it can be responsible for enabling other reference features in your complicated drawings. When you go to make parts that are real parts and real fittings and things like this, your referencing will change and scale much better. You can end up with all kinds of issues if you have to change a feature type 3/4 of the way through the design. Now, those of you that have had a little more experience with this, what do we need to do to this rectangle to get it fully defined relative to the origin? What information does the computer need? Because it knows how big it is and it knows that it's referencing here, but what information is missing? Yeah, the location. So we need to define the location, but we need a little bit more information than just the distance, right? And I'm about to show you why. So if the distance actually needs to be 60 millimeters, incidentally, another way that you guys can cheat is you can enter alternate units here. The default, since I'm in MMGS, is going to be 60 millimeters, but you can specify the abbreviation for millimeters when you go to do this. So 60 millimeters. So it should know where it is now, right? Problem is, if I now move this, let's get it to reload the dimensions. See what's happening? So what information is defined because of this? That actually set a radius to this point. Is that what we were hoping to do? Not quite. But because this is a circle, it still doesn't know where it is, because it could be at that radius and satisfy all of these requirements at literally about any position here. So instead, we also need to define how far away it is by selecting our smart dimensions and telling it here what this distance is. So you have a couple different options in terms of how to define these and how to pull the leader lines out. You just want to pay attention to the difference between horizontal, diagonal, and vertical, because those are very different kinds of dimensions. So right now, this is the one that we're missing. And if this needs to be, say, 24, then we know where it is relative to this. But if we want it to stay with our original ratio, we actually want this to be 22.5 millimeters. And this will relocate everything so that now we have square reference points again. So we want to pay attention to where the object is relative to the origin, and then it will always know what exactly it's doing. So there's a whole bunch of reasons why we want to do that, and we'll see some examples of when that's actually really helpful later on. So now that we did all that hard work, I'm going to delete all of those. What we're going to do is we're going to turn this cylinder into something sort of resembling a coffee mug. So we're going to start with our first operation. Now that we have a fully defined sketch, I'm going to suggest that you do what I call stepping out of the sketch. So you step out of it, then you go over to features, and we're going to do an extrude. It's going to assume that this is the geometry, since this is the only geometry in the area. That's going to be correct. And we want to do something like 150 millimeters. So that may be a little bit tall for this particular aspect ratio. So maybe we'll do 130 millimeters. There's a few variations of these. We'll talk about using a similar operation, what the differences are. Much of the time, you're going to be doing a blind extrusion up to a certain height. There's some fancier variations of this technique we'll use later. So here we have our first simple cylinder. So we've gone from a 2D idea to a 3D representation. So you guys will probably not have all of the shiny sort of chrome-like features enabled. That's a graphics card setting that some are on the approved list, some aren't. It's not important to have that. I think we got rid of some of the real view graphics and other things that some laptops weren't able to do anyway. So a lot of that headache has gone away from this class, which is good for you guys. All right, now we've got this. But when we go to look at one of these first assignments that we're doing here, the Intro to SolidWorks, you want to pay attention every time you go to do these, so that you're looking at what is attached at the bottom of those assignments. So there's specific objects that you need to be drawing. And so one of them is a cube, one of them is a sphere, and one of them is a silo. So there's a couple ways that you can do a silo, and we're just going to focus on a couple variations of that because of how we're going to make the sphere. So what we want to do is we want to start by adding another element. There's a couple ways to reuse the base sketch. We'll probably cover that a little bit later. We're not going to do that one in this case, but you're going to need to add a new sketch. And you can do that one of a couple ways. So when you've stepped out of a sketch, you've stepped out of an operation, you've run some feature operation on that sketch to do something like an extrusion. What you want to do is add another sketch for some additional detail or some additional object that you need. Now, I'm going to do this a little bit differently so that I can demo a couple of things kind of at the same time. We'll hit on this a bunch in the near future. What I'm going to start with is if we were going to add what's called a reference plane. So here, instead of selecting this, I'm going to set a manual reference. So a lot of times when we're doing a plane or starting a sketch, we're going to have to expand this part tree and reference one of these other planes. So in this case, I'm going to reference the top plane. Sometimes we may want to reference the object that we just did an operation on, whatever that feature is. Sometimes we're going to reference that sketch, and we're going to want to draw another sketch sort of superimposed on that one. It depends on what you're trying to do and how many design iterations you're going to need. For this, I'm going to show you how to do a simple reference geometry as an offset plane for that same height. So distance is going to be your default. And we said this was 130 millimeters. And one of the big advantages to having a mouse is you can hold down the scroll wheel and move this. So the view, especially those of you that are working on trackpads, view orientation, you want to come up here to view orientation. So I started off with a top plane view, which was here. Then we did the extrusion. And then sometimes when an extrusion's done, it will go to this corner one, which is an isometric, but this is the upside down isometric. So what I actually want is this one right here, which is the top side up isometric. So a lot of times it goes to this view when you do an operation. The one that I'm going to recommend for the process that we're going to be doing is you want to reset your view anytime you're going to be adding a sketch to something. You want to reset your view to be looking straight on whatever your sketch plane is. There's a whole lot of reasons for that, and I'll demo why right here, for instance. So in this case, if I add this plane, because I've set a distance and I've referenced another plane, this is a fully defined plane. So to accept that, I'm going to hit OK. So now I have my first reference plane. What this is going to let me do is add a sketch element. But the first thing that I'm going to do is a center line. Now here, what I'm going to do is I'm going to do it this way for a second, just because this looks like, and the escape key, that's another one of your big friends in this class. So the center line looks like it's running through the origin, and I should be good to go. And I'm going to do a center point arc. It's going to sort of naturally gravitate to, let's see, where can I do that? Yeah. So here, you're going to see the blue line fill in where it goes. And it's going to be connected. And then we have an arc, but we're going to do another one. We're going to do a circle to show what that's like, because there's a technique that we need to be able to use to get to the result that we're looking for. So I'm going to do a circle first. So I'm going to remove that arc. I'm going to do a circle. Uh-oh. Well, what's going on here now? Wait a minute. Remember I said that thing about you want to be looking perpendicular or straight on to whatever you're drawing on? There's no view that I can do where this is correct, but it sure looked from that angle like we were going through the origin, right? So there's a couple ways to fix that. One of which is you can move things around with a smart dimension. This is a technique that I want you guys to get familiar with. So if I wanted to use the midpoint of that line as a reference, I'm going to use smart dimension. Occasionally, it will pick the incorrect tool for the job. So it's just something you have to be aware of. So in order to get this fixed, this is actually where the origin is. If you're ever struggling with a view and you don't know for sure, what you can do is you can come over here and you can specify the origin. So especially those of you that are experienced, what you can see is there's some other reference point here, but then the physical origin is way down there. So this is why you want to really, really, really pay attention to keeping your orientation square when you're looking at different views and options. So I'm going to fix this using smart dimensions first. Then I'll undo all of that and show you how to do it right the first time. So now the circle itself, I want to set the distance between this and the origin to be 0. That will move my circle over the origin. And now what I can do is I can select these two dimensions and get a thickness and say I actually want these to be the same dimensions. So now we can see I have a fully defined sketch. So it knows, even though this is now at the top of our cylinder and it's separate from this other sketch that we were working on. So there's sketch 1. Here's sketch 2 that we're working on now. This is fully defined. So this is very, very important for what we're going to be trying to do. So you want to be very, very mindful of the view and orientation when you're working on things. This becomes ever more critical when you're working from complicated drawings with features on all different faces and sides. It's really important to keep track of which face you're on, especially so that you think that you're drawing on the top, because unfortunately, if I manually show you this one, if we look from the bottom side, we're still working on plane 1, but our features now might be, they might be different than what we think. So if we were doing an arc or a partial design and it was only on one side and we needed a concentric arc out here or something, what this is going to do is actually be on the opposite side of what we thought it was on the object relative to its original orientation. So you really want to pay attention to which view you have up. And that's why I say you always want to go back, re-square your view, and get used to using that particular tool. So to step out of that arc tool, again, the escape key, this arc we don't actually need. So I'm going to delete that. Now, what we're going to do is teach you how to use another one of our tools. So I'm going to step out of the sketch, go over to our features, and do a revolve. Now, it's not going to know automatically what I want to revolve because there's more than one object in this drawing. So on this sketch, once I reference the sketch, it'll say, oh, hey, I recognize there's a line, and I recognize there's some kind of symmetry, some kind of contour. Now, in this case, we're selecting the entirety of the circle. So one of the questions that we are going to try and answer is, can we get this to revolve? And this line is this central axis, or this center line. That's our axis of revolution. So if we try and do this, we get errors. This self-intersecting problem is very frustrating and will come up a lot. And what I want you guys to do is I want you guys to pause when you see that error and think for a second about what does it mean with internal self-intersecting cross sections or center lines or whatever. If we're trying to rotate this whole object around 360 degrees, that means taking the object itself and revolving the whole thing 360 degrees, which creates the same internal volume approximately 4 times rather than just once. So because of that self-intersecting internal volume that this creates, you're going to have a lot of problems with it. So instead, you want to be able to select contours. So if you just select these contours and then tell it, I actually only need 180 degrees, not 1800. That's hot enough to melt aluminum. We're going to go the opposite direction. So when we need to flip direction of an operation, we hit this arrow. That's usually going to be direction. This is going to be very, very important. Another quick note for any of these kinds of features, extrude cut, revolve cut, etc. If the thin feature is selected, that usually means that you have some kind of open geometry taking place and you want to stop and figure out what's wrong with your base sketch. There might be points somewhere on your sketch that no longer connect or are not coincident. So the thin feature tells you that there's probably some kind of a problem with the sketch that you're using to do the operation. That'll make sense later when you see some examples of it, but I just want to point out to you that should basically never be checked for anything that I've had to draw ever. And I have more 3D printers than I actually know off the top of my head I have. It might be 13. I'm not sure. I can stop anytime I want to. Don't worry about it. So when we're done with our operation, we hit the revolve. So now we have a silo, and that's great. But then we go back and look at the instructions, because it's important to do that sometimes in life, and go, that's not right. Well, it turns out there's some dimensions down here, and we probably should have paid attention to those. Oh, what? That could be part of my problem. So since I did the wrong dimensions, now I need to go back and make some adjustments. So I can do that by actually editing the feature itself. So it's not the sketch that was the issue. It's the operation that I did to the sketch, or the feature that I operated on the sketch. And this actually needs to be more like 30 millimeters. Okay. So then I do that and it's fixed. Well, that's embarrassing. Okay. Smart guys, what was my mistake there? What did I do wrong? Or how could I have done that differently so that that didn't happen? Because now I got to fix it, right? Let's see a vote in the chat. Is it going to be easier to fix this? Or is it going to be easier to just start over? So yes, you can move the sketch plane. And that's what I'm going to show you now as a trick. So we can always come up and edit a feature. And for planes, you can add a sketch right here. So those are both useful tools you're going to use a ton. So really get familiar with the right click and then edit feature, edit sketch, or edit feature, add a sketch, because those are going to really, really help you. So I had referenced that top plane and set a specific distance. So this is why we need to kind of think through a little bit what our process is going to be and what kind of thing that we're drawing, but we need some experience first. So instead, I could have referenced, instead of that top plane, I could have referenced the sketch that we drew, or I could reference the top of the extrusion. So that edge, or I could reference this face, but I want to make sure that I'm either using parallel, or in this case, coincident, because that's going to pick a point, in this case, this one, that's the start and end point of that circle. Coincident means that plane is going to always be touching that face instead of setting it as a distance. Alternatively, I could say I want it to be a distance, but set it at a 0 offset. So more often than not, I'm going to recommend a 0 offset from a feature like a face rather than coincident, because of some of the geometries, like when we need to do a reference at the surface of a cylinder, what you guys are going to find is you can't just click, I'll show you real quick, the surface of the cylinder and expect that it's going to understand what to do with it. Because you could even then say, well, I want to select that edge and then On the third one, I want to select this edge. So even though you've kind of defined 3 points and that should make a plane, this doesn't work because reasons. So instead, we want to delete those. And whenever you get into that situation, you go in, delete references, you come back to this and go, okay, I want it to be a 0 offset. So a distance offset of 0 from that face, and then hit OK. And now that plane, no matter what we do to this operation, if we take this back up to 350, or if we take this down to 110, that plane and that second feature on the plane, this dome, is going to follow my sketch if I have to change dimensions later. So that becomes really, really important to be thinking about referencing if you need to make changes in a design. So again, this is starting to put concepts into your brain like seeds that will grow up into full-grown plants later, and you will have complete understanding of things. But there's a lot of intermediate steps and processes that you really need to grasp in order to get very good at what this is. So there's some other ways, but those are the ones that I'm going to recommend being able to do something like this. Now, having seen these techniques, is there a better way to do this operation as a whole because of what's called the symmetry of the object? Any ideas? The dome feature is one. Revolve is another. So let's take a look at a revolve and see what that process would look like. So I'm going to come back to home. I'm going to do a new part. And once we learn how to do some more of these, I'll do an example with this kind of mug. So for this one, I will pick right plane because right plane doesn't often get a whole lot of love. I'm going to start with a center line, which is something I'll do often depending on what it is that I'm actually trying to accomplish. So I'm going to scroll back and zoom out. Another thing that you guys are probably going to want to change that I didn't think to mention in the earlier class, rather than finding it manually, up here, search on invert. Oh, you dog. Right here. Select reverse mouse wheel zoom direction. It will change your life. So unless you're one of those people that loves to scroll up to go down because your brain works backwards, if that's you, keep it normal ways and it'll make sense to you. It absolutely drives me bananas. So make life a whole lot easier on yourself. So I'm going to do some lines for this one. No, I'm going to do a simple rectangle just to keep life a little easier on you. All right, so a simple rectangle. We set our smart dimensions to get something set up first. Sometimes you have to click it twice. Just reasons why that happens. So let's say 75 millimeters, and let's set this thickness to about what? Let's do 18.5 millimeters. All right. So now we're going to need an arc. A couple different ways we can do that. We can either do a circle. So I need the circle to actually start where I tell it to start. So with the scroll wheel, you can also zoom in, which is what I was just talking about as far as techniques. So you can do a circle this way. Then you can use what's called the trim tool. I recommend trim to closest. You can use power trim unless you're on a touch screen, in which case power trim is probably a terrible idea. And then you have your dome feature, but it'll create some unusual issues. So I'm going to go ahead and cut that out. And we'll use center point arc as we ought to. Now, it's a 50-50 chance whether or not your arc is going to go the right direction. You might have to move the mouse back and forth around whatever your object is, whatever your reference is. In that case, it was this point, in order to get to what you're looking for. And then I'm going to create just a straight line segment here. No, a straight line segment. So maybe don't buy the Amazon mouse sort by cheapest. Sometimes their left click switches are not top binned parts. Okay. Now, because of the continuous geometry that we're going to have when we're trying to do a revolve in order to create less confusion, we're going to want to trim out a section so that we have a simple enclosed volume in order to avoid those internal geometry conflicts. Technically, this would have been the same, but I want to get you in the habit of deleting things to show that this color change tells you that you have a complete, what's called, quote, watertight 2D surface. Bunch of reasons that turns out to be helpful, but we won't go too far into that right now. That's for some later lessons. So we're going to go back and do our revolve. It will automatically assume 360-degree blind revolution. This one is going to look the same either way. Because we have a fully enclosed volume, we don't have the thin feature, and we don't have to select the contours, but I do want you to get in the habit of knowing what this is and how to select the specific regions you want. We'll look at an example in a few minutes with like extrude and extrude cut, where you want to have control over which contour you're doing the operation on. So there we are. Now, that was a whole lot faster than the first one. And what we're doing is we're leveraging the symmetry of the part, because this is the same along all of these axes. You're able to leverage the symmetry of the part when you do a revolve and features like that. So there's a lot of benefits to being able to do that. There are some other ones that you can use. There are a bunch of other tools that you can access. There's a lot in here. So Dome is one of the ones that was referenced. So these are ones that aren't in the normal operation here. They're not in kind of the normal quick links for the command manager, but they are there if you want to learn how to use them. So there are some options. The good news is this is a lot quicker operation than some of the others. So let's take a pause for a second and see what kind of questions are coming up. So we're going to do another type of sketch now. We'll start with another new part. Okay, so we're going to do another new part, and what we're going to do is go back to our sketch. This is going to be looking at how to, we'll do maybe a simple example of an erector set. There's a piece, there's a few different ways to do this, but this will give you another kind of 3 or 4 techniques that can be used for the same things. Some of these are going to be used for a couple of the tutorials that are due. So you're going to see a bunch of these again anyway, but I wanted to go over several of them. So this one, we're going to do a sketch on the top plane. Note that whenever you see this, you're not really in the view orientation you need to be doing a drawing, because you could lay this out, but you're going to quickly see that you don't really have a good spatial sense of what's going on there. So you want to make sure, again, reset the camera view in order to know what you're doing and where. There's a few different ways that you can set something like this up. I'm going to use smart dimensions to move this around just to get you guys in the habit of knowing that if you place something incorrectly, that's not the end of the world. Real quick, I can show you, especially before you add any smart dimensions, the drawing is not, quote, anchored or fixed in the space. So you can just free drag it if you completely botched it and forgot to do the view. So you can also do kind of a free dimensioning to get it closer to what you want. But it's not necessarily going to just like snap to the origin or anything like that. So you don't have an easy way to make that happen. This time I'll go on the left side. So what you want to do in that case is leave yourself enough working room. You don't want to put it really up close because then you have to zoom in, zoom in, zoom in, zoom in, and makes life very, very difficult. And then you get to see where geometry of things, especially like polygons, for instance, when you zoom in, zoom in, zoom in, when you get in really tight, you figure out that at the end of the day, these geometries are well and truly just a group of pixels all stuck together. So you can get to a point where you zoom in far enough that things will look almost like they're misaligned. In this case, the polygon isn't, but some of your other drawings and features, when you start adding and deleting lines, you can get all kinds of bizarre behaviors. So since I don't need this, go ahead and delete it. And I'm going to use smart dimensions to do this. So smart dimensions are going to move right here. Select our origin and this point. So again, make sure that you're pulling vertical and horizontal, setting them to 0. Same deal here, setting them to 0. All right, now 2 of our lines are fixed. This isn't now a fully defined sketch, but that's okay. We're going to say this is 100 millimeters long. And then the real trivia question about how wide is a flat bar with all the holes from an erector set? Anyone know off the top of their head? That's why one of the other things that you may want to pay attention to getting yourself is a set of calipers for your own use. They turn out to be really, really useful for a whole wide range of reasons. And looks like I've got some little bit of metal debris I've got to kick out of mine. So what you're going to have is a measurement here that looks like that's going to be about 12.5 millimeters or so. So I'm going to go ahead and pause this and let you guys get a little bit caught up here. All right. Hazards of the job. So there's going to be a midpoint that you can find of all of these. Any of these lines is going to have a midpoint that you'll be able to determine. So in this case, I'm going to do a center point arc. A lot of times it'll start out doing the wrong direction. This version seems like its logic at guessing center points has improved. So that's a good sign. I'm testing it in a couple different directions and it's more or less doing the correct-ish things. So I'm going to go ahead and since we're building an erector set piece, I'm going to trim out these sections. There we go. So we've got 12.5 as our height. And we're going to add along the center a center line, because we can still do that. This is going to let us leverage another really, really important thing, which is patterning. So these will need to be, what are these? Most of that I want to say is like M3 to M4 hardware. So somewhere around 4.2 millimeters should be sufficient. So 4.2 millimeter diameter, and then a linear sketch pattern is another tool that we'll use. You'll see this used in specifically the circular sketch pattern. You'll see used in the tutorial. So we'll go over where to find those here in just a couple seconds. So this we can copy. So this is going to be along the x-axis, and it's going to be the entities to pattern that we want to select. And we tell it how many we want. In this case, I think we want, what is this? 8, 12. It's like the 100 millimeter variant is 11 of them. Yeah, that sounds right, because there's a 10 mil pitch on that. So yeah, that would be correct. So this is what we would do. We would have these sections, or this particular pattern that we'd be using. We're going to hit OK. And what this does is we want to be very careful about getting all of our geometry set before we do the patterning. We can go back in and make a change and go, oh, whoops, that was actually 4.5 millimeters. And this linear pattern will correct itself. But there's a certain point at which you won't be able to make adjustments to whatever that base geometry was, especially if you do the pattern in like a couple different directions. Maybe some of those features work a little better in the new ones, or in the newest version that we're running now. I'll let you know as I come across some of those. But the good habits of old have been, make sure that you get your geometries and your pitch, meaning the spacing, center to center spacing. So the distance from here to here, I'll measure it just so that you guys can see. This will probably give me a flag and saying, oh, this is overdefined, but since I don't have a fully defined sketch, this won't yet. So 10 millimeters. Yes, that is correct. So what this will do is anchor our design. So we would have to specify a few more things as far as total dimensions. So 12.5, that's an important one. And our arc is going to be the same, 6.25. So I'm trying to get that over definition flag so that you guys can see what I'm talking about, because it turns everything yellow and says, the universe is exploding. All right. 6.25 in height. There we go. So now I can get an over definition, and we'll just randomly say the spacing between these two. There we go. So this is what it will look like. You will run into this very often, whether you're making a dimension driven or leaving it driving. Making a dimension driven means that it will change with the other things. So it will leave that highlighted, and even when you select off, it'll stay a different color. Really, for this, for full definition, you can go in and delete them. For this, I don't actually think you need the radii. Yeah, maybe I guess you do need both radii, because you need to set a couple of those key points. So probably because you need to specify that this isn't a farther arc. So the reason this is important, I'll show you why, is this actually could be 7.25, for instance, and you wouldn't have a fully defined sketch because now you shift that point of origin and there's not a fixed distance between this point and where the origin is here. So the way that the definitions all tie together in the software become very, very important for a range of reasons. So a lot of things are dependent on a lot of other things. And when you change one feature, you change a whole chain of reference points. And that's why it's important to start at least seeing this and start thinking in terms of what else am I going to mess up when I adjust this dimension? And then how do I go back and fix it? So there's another kind of quick live examples there. All right. So now we've got our fully defined sketch. We're going to step out of the sketch and we're going to go to the extrude. It's often going to guess when you have a pattern that you want holes through the pattern, and that's usually going to be correct. So this thickness is going to be about 1.5 to 2 millimeters. 1.5, I think, is the standard thickness for an erector set piece. So any of you that actually have played with erector set or are familiar that that was even a thing, it's a good chance that you would have been born before the year of our Lord 2000. Okay. I'm one of those ancient fossils from back in the 1900s. All right. On the office hours question, no, I don't have office hours as I'm no longer on campus and I'm not a full-time faculty. We don't tend to have office hours available. So I've got a lot of other time commitments that prevent me from being able to focus on this exclusively as I'm running different parts of operations in the other 3 businesses. So a whole bunch of things going on in the background. So now we have our part and we have our example where we've used our linear pattern. So this is, again, covering kind of some techniques from what would normally be the first kind of 3 weeks or so. There's a lot more to this. I'll go back to that sketch so that you guys can see, so that you guys can get key information about these. We'll talk real quick about the mechanics of assignment submission here. So we can get some information when we select something like the boss extrude, but it's only going to tell you information associated with that operation. Sometimes if you can select the base sketch along with the model, you're going to get more detail. So what you're going to want to do is I will often have the snipping tool up. I'm going to take a screenshot. And what I'm going to do is I'm going to include this material. So this is the expanded part tree that's going to tell me what kind of operations that you did. Then we're also going to include some kind of view with whatever dimension detail we can of our particular drawing. And at the bottom, we want to try and include information about what ungodly hour we're doing all of this process at, because it's always interesting to see who's actually started this at 11:58 p.m. on a Sunday night, and how quickly they were able to put together the sketch. So that time feature is mostly for the private entertainment of the instructors, but it does actually help to give a sense of what's happening. And if by some coincidence you manage to be in 2023, or you're doing a sketch and it's all the way back in 2020, we can ask what the secrets of time travel are, because that's also helpful to know. So all in total, what we're going to have is the part tree, the part itself with whatever dimensions you can get to show are possible. You sometimes want to show a couple of the steps along the way, so you'll take a couple different screenshots. This matters for much more complicated parts and assemblies, more so than it does kind of early on. We just want to try and show as much as we can in terms of dimensions, because it'll be obvious if the aspect ratio of something is just way wrong. But it won't always be obvious to know whether or not you have complete command over the specific dimensions that we're targeting. So that's one of the things we want to pay attention to. So then what you'll do is you'll take this screenshot, you'll copy it, you'll drop it into a Word document. I don't think I've got, yeah, I do. So I'll bring this up. You'll copy it into a Word document. Make sure you have your name, your class section, what the date is. So again, if it's all the way back in 2020, that's going to be quite a trick. You're going to show whatever dimensions you can get to show. You're going to show your part tree expanded out so that I can see how you're thinking about creating these parts. And you're going to show what dimensions you can so that I can make sure you understand how to get to fully defined sketches. You understand what the dimensions are and how they operate, and then what interesting time of usually very early morning you guys are working, because that's a thing that usually happens early in the mornings, often the night of or the day after the due date was. So keep in mind your 10% per day late policy so that everybody knows what to expect. That way there's no discussion and whining and sniveling in the message section. Keeps things simple and everyone knows what's coming. All right, so different examples of parts that we can make. Lots of really cool complex geometries that we can make already with the features that we've learned here. But again, I also recognize that I'm hitting you guys pretty aggressively with content. So we're going to pause again and then check for questions. We're going to cover another technique here where we're going to start another new part. And one of the other things that you're going to need to be able to do is similar to the extrude base boss, but what we're going to do is an extrude cut. So what this will do is basically the opposite. Most of the operations in SolidWorks are going to be behaving like one of two different things. So one of those is going to be you're adding material. The other is going to be you're taking material away. So think of these drawings in terms of how you would actually build a part or component. And for something like that, bar, we could do the same kind of thing. So we'll do another kind of variation of this. I'm going to change my view, make sure that we're with a square orientation here. So we'll do the same kind of deal. We'll do 100 millimeters. We'll do 12.5. We'll do center point arcs. Yeah, so far it seems like some of their referencing in this version has improved, so that's good news for you guys. All right, so we have our enclosed volume. We're going to set our smart dimensions here. 6.25 and 6.25 radius and a 6.25 radius. And these two. So because we've already got, because we've got 12.5 already defined. There we go. Fix the other endpoint. And we've got all of these other bits and pieces. There we go. We're going to do an extrusion now that we've got this fully defined. And then in the chat, give me a guess as to what you think we're going to do next to use an extrude cut. What would be the best next step? See what you guys think. What would be the best next steps? Because there's a couple options we can pursue here. I'm going to change my view to be a top view, make things a little easier. So we can do a new sketch. We could do a reference plane for this one. It's not needed necessarily. But we can do a new sketch. I want to get you guys in the habit of knowing exactly what you're referencing. So I want you to get in the habit of expanding the part tree whenever you see this box, in case you need to reference something like front plane, top plane, right plane, because that will come back to be very, very useful later. So here I selected that top face. Now we're going to do a sketch. And I'm going to need a little more help here. I'm going to cheat. And even though this is a top plane sketch, what I'm going to do is, again, get you guys into the habit of resetting the view. I'm going to add these circles in. Now, the question is, you want to find the reference point, and here it'll give it to you. So we decided that these needed to be maybe about 4.5 millimeter. I think about 4.5 millimeter feels right for the aspect ratio. And you can see this is already fully defined because this is referencing the center point on that arc, the center point of the radius for that arc. So the center line of that arc and the center line of the other arc. So it knows where everything is based on the reference to the other sketch. Even though you can't see that other sketch, it understands, because of that full definition, where things are. So we don't have to specify as much this time around. We can just do our linear sketch pattern. So it's still going to be along the X axis. So we're not going to do copies along the Y. There's also a third direction that you can add a whole bunch of things. So here we want to go back and do our total of 11. There we are. And now we're going to do, instead, while we have these selected, while we're in this sketch, so while we have this selected, we can go ahead and hit the extrude cut. And this will make a reasonable assumption that we want to cut all of those holes through the part. So this is thinking about operations as if you were to be drilling the holes in this real physical part. So this is useful for a number of reasons, because you can start thinking about, okay, if I would be drilling a hole or sanding something, if I were sanding off the corners of something, we'll take a look at fillets as well in a second, because that's something else that they're going to reference in one of the tutorials, one of the first ones you guys are doing this week. This is the kind of operation that you would be doing effectively on the material if you were to punch out all of these holes using a drill or something of that nature. So there's a couple different options. Sometimes you need a through all. So we'll look at an example of the difference between a blind extrusion to a certain depth. So if we just did a blind extrude cut to 1 millimeter, that would look like this. We've got our holes on one side, but not on the other. So sometimes that's useful. There's a certain plunge depth that's needed for some types of parts. Other types, you actually want instead, you want a through all. So that looks a little bit different. So there's our part. And you can see that if we line that up side by side, this is not a recreation of our other part, but we did an extrude of a single part. And we did, for this one, an extrude and then a cut extrude. So this is why I want to see your process, how you're thinking about the parts, so that I can make comments on, hey, you should try doing this, so that you can start thinking in a specific way. Because what this will do is this will make a difference in how you're actually creating the parts and how fast and efficient you are at things. So this will help me to gauge much better, in a way that only an experienced set of eyes will be able to tell how you guys are thinking about the parts, geometries, and symmetry of whatever component you're trying to recreate. All right, so there's a couple others real quick we'll take a look at, and then I'll do another question check. So there would be a slight, what's called a fillet on the real parts. So here, we need about a 0.25 millimeter fillet. I don't actually want the face. I actually want the edges. Are you going to let me select them? No, you are not. So this kind of object is, you can sometimes get away with grabbing one of the edges. The problem is at such a small extrude thickness, these are such small features that it's often going to be very difficult to actually select something that's not a face, so like an edge. Whereas one of the other things I wanted to show you guys is if you have that dialog box open, and you haven't completed something, you come over here, you can switch windows. At least you used to be able to in the old one. Maybe it won't let you now. Oh, interesting. Okay. So it won't let you now, because one of the things that would do is it would lock the window, and that would always frustrate the potatoes out of my students because they would try to go do an operation and it would make a mess. So here, if we go to do a fillet, we could select this edge. No, clear selections. So we should be able to select this edge. That is very interesting. So that edge exists. The tangent dimensions shouldn't matter as much. Interesting. You haven't option where you can select a full round fillet. Constant size is usually the ones that I have selected. So when you're in this mode, it looks like maybe this is the default to do a face fillet. I tend to not like how well that operation works. It works mechanically, so I'll show you how to recreate that, but that's why it wasn't letting me select faces. I tend to want to select the individual items because that gives me a lot better control on which edges to actually do the filleting on. And you can do symmetric or asymmetric. So depending on what kind of effect you're trying to go for, you can have an asymmetric fillet. And so you see that kind of geometry starts looking a lot like something like the stamping that you might find on the bottom or base of a coffee mug, which unfortunately is empty. That's always a bad life choice. So make sure coffee mugs aren't empty whenever possible. So jumping back over to this part, you can do fillets with those faces. But here's one of the problems that you're going to encounter with that mode. So you have to select the one face and then the other face like this with the two different colors. It's symmetric. It's doable, and it's going to need to be 0.25 to be like the actual part. It's going to have to be like a 0.25 millimeter radius. It can become very cumbersome to try and pick up those faces. Or if you only want it in specific instances, maybe you wanted that edge to be flat because of some constraint or design element in the part. Some clear selections. Interesting. Yeah, so I'm going to delete this entirely. No. I'm going to delete this feature, get rid of it, and go back to do a fillet using the other method, which is my kind of preferred method. I can select each of those edges individually, and maybe I'm trying to represent only part of it. This gives me a little more perceived control over the details. So if I do one fillet operation, then I hit OK. So this allows me to do either a fillet or a chamfer, which may also, I'll do a chamfer on the other side just to demonstrate what that looks like. Let's do a little more aggressive one, a 1 millimeter chamfer. We'll leave it symmetric at 45 degrees. So on this side, we can see what that looks like. Can anyone think of an idea for why you would want to do it this way for a part? Why would you want something like this kind of a feature on a part? What would be the point of having a chamfer like this? Exactly. Something like being able to have the head of the fastener sit flush. So that's one of the instances where you might want this kind of a feature, but you want it only on a certain side. And maybe on the other side, you want to deburr, which would be more like a fillet, to deburr the hole so that you could get hardware through this. What's an example where these kinds of machining processes would be really important, and they would use these exact kinds of machining processes? Anyone have a bunch of metal hardware holding together one of their joints or bones, or has a good story about that? So medical implants are often going to have these kinds of chamfers and fillets and things to make sure that when that metal part is implanted, there's not going to be any machining debris, any burrs, any sharp spots to irritate the tissue around it, because otherwise there would be a lot of swelling for the patient and cause a lot of difficulty. So you'll see very, very highly machined parts. Oftentimes, in fact, a lot of the parts that are going into surgical implants are starting to be 3D metal printed so that they have innately smooth geometries, and are more friendly to the surrounding organic tissue. So there's a whole bunch of reasons why you would have a feature set like that. All right, so we're going to pause for a second there and take a look at other questions. So let's do one more example. So I'll start another new sketch. Actually, before we go there, I will, sometimes the download will have a failure. So what I'm going to do instead, real quick, is before we start another example part, I'm going to show you a couple things about where these are. So you go to the Home tab to Learn, and then step-by-step tutorials. This is going to bring up another window. This is working a whole lot better with this particular monitor configuration. One of the other things you guys will see, I wanted to be able to catch this on screen. If you see this really, really fine print, this is an artifact of your screen resolution. So a lot of you have probably at this point 4K screens. So your native resolution may be higher than 1920 by 1080. Windows is miserable at scaling the interface. So it doesn't really understand well how to do that. So it'll come up with this really small text. The way to fix that is to run in 1920 by 1080 resolution instead. But I wanted you guys to see what this looks like. So they have a couple different options: getting started, basic techniques, advanced techniques. So some of these tutorials, especially from basics and from getting started, we're going to do. The first one that you're required to do is this Introduction to SolidWorks. So this is where it's located, going to that Home tab and then Learning, and there's step-by-step tutorials. So down here, there'll be this little tiny microscopic button. And what this will do is when you go to create a new part, it will walk you through where some of these are. So it'll say, hey, click on New. Hey, that's up here. And then it'll walk you through a couple things. Then it'll say, here, do these things, and you'll see that some of their instructions are sort of kind of a little bit out of operations. So they'll say, yeah, click on this extrude, and then hurry up and click a circle. And so that's a kind of a bass-ackwards way of going about it. So I recommend just starting your sketch anyway, and then going through the operations, but it'll say, okay, where is this thing? It'll flip over to the basic feature and highlight it for you, which turns out to be really, really helpful. Same thing with the circle. We'll go, oh, hey, it's over here. It'll talk to you about what these lines indicate and some of the stuff that we've covered here, using smart dimensions, how to exit the sketch, etc. There are a couple points where students tend to get stuck. Saving early, saving often. It's a really, really good tip. SolidWorks has a tendency to crash, and there's never a convenient time for a crash. So it's not that it's totally failure prone. I actually have very few issues with it on average, but when it does crash, it crashes hard and fast, and there's no warning. So there are instances where students have gone a couple hours into a part, and then something happens. Windows tries to go and update, and SolidWorks crashes, and then they lose the part because they didn't save early, save often. So do yourself a favor, do that a little bit better. All right. So it'll go through some more things, and it'll help you find where the views are. So in this case, it'll bring up this toolbar and say, hey, look here, and you may want that toolbar anyway. So if you're working on a really small screen, like on a Surface or something, you may want to hide away the ribbon. You just don't want to get rid of it entirely. So there's different approaches based on what you're working with. And then it'll walk you through some of the other things, how to use a couple of the copy entities features, how to do a circular pattern once you've got this set up. There you go. So when you put all this stuff together, you get a pretty cohesive picture of what's going on. And then you'll get a final part out the end. So by the time you get through walking through this tutorial, going back through some of the videos the video that we've been developing today, working your way through those parts, especially those of you that are still in the download phase, fighting with internet and all the other things, this will give you a much better idea how to kind of get some things going in the software. It'll start to get you some ideas how to troubleshoot things. And since you're probably going to end up on YouTube looking for tutorials on stuff anyway, that's why I'm going to be recording the classes. So any other questions as we go to close out today? Or any other things you guys want to see a lot more of?